Hi guys, this video is for those of you who were not here on Tuesday or Wednesday, or for those of you who were here that just need a little bit more practice or review. So to start off with, we're going to just think about these four questions. What is a reciprocal? What is an inverse? How are they different? How are they similar? Take a minute to just free write off to the side. What do these words mean? How are they different? How are they similar? Class, there's no real way for us to kind of hear different people's reactions, but these were some reactions that kind of came up over the course of the last couple of days. So with a reciprocal, we use reciprocals when we are finding flipped fractions. So a reciprocal is a flipped fraction. An inverse, often with inverses, we think of operations like addition and subtraction are inverses, or multiplication and division are inverses. Some ways that they're different, this came up a lot in a lot of different classes. Reciprocals are typically, you're dealing with a number. So you think about a number and you're flipping that, whatever that number is, versus an inverse, you're thinking of an operation. But they are pretty similar. They feel similar. They're both, like, in some way, an opposite of what you would think for one another. So the reason why I wanted to start off with this is because I just want to emphasize that these two things are different. A reciprocal and an inverse are different, or mean different things mathematically. Today we're going to be focusing on reciprocals, so you probably want to get this definition down, that a reciprocal is a flipped fraction. Okay? And let's take a look move on to some content. So we've been talking about trig and trig functions. Today we're going to be talking about reciprocal trig functions. So we have our regular trig functions, and we've got three of those. So not talking about inverses now, just reciprocals. We're going to ignore inverses for just a little bit. Our regular trig functions, we know we have sine of some number. We have cosine of some number, and we have tangent of some number. And those are kind of our three regulars, our three starting points. Well, each of these have a reciprocal function. The most basic form is that each of these fractions can be put, or each of these values can be put over 1. They're all whole numbers, so if I were to take the reciprocal, I'm just flipping that fraction. So my reciprocal of sine would be 1 over sine of that same value. Reciprocal of cosine would be 1 over cosine. Reciprocal of tangent would be 1 over tangent. And those are kind of our starting places. To make this just a little bit more complicated, and I recognize that it is complicating things, these reciprocals actually have their own names. So 1 over sine of theta is the same thing as cosecant of theta. So these two statements are equivalent, they're interchangeable, and I'll write the name down just so that you can understand what it's saying. Cosecant of theta. 1 over cosine of theta is equivalent to secant of theta. Secant. And 1 over tangent of theta is equivalent to cotangent of theta. Cotangent. Okay. One thing I just want to recognize is that the naming of these is not ideal. So looking at the names, I might assume that cosecant goes with cosine, just because they both start with CO. But it's actually the opposite. So cosecant goes with sine, cosine goes with secant. It's a little bit weird, but just something to point out, maybe to help you remember it. So we're going to I'm going to move this up just a little bit. We're going to practice with this, or with this idea, with some practice problems. So if I asked you to find, let's say, cosecant of 60 degrees. At this point, you want to have your unit circle out to use as a reference, and we will keep moving on with this one, but go ahead and pause to take it out. Great, so I've got my unit circle. Before I look at it though, I'm going to just find my equivalency. So I know that cosecant of some angle is the same thing as 1 over sine of that same angle. So I'm going to have 1 over sine of, in this case, my angle was 60 degrees. Okay. So from here, I'm going to look at my unit circle. I'm trying to find sine of 60 degrees. So I'm going to go to 60 degrees. My sine value is my y value. So sine of 60 degrees is root 3 over 2. I'm going to replace that over here with sine of 60 degrees. So I'm going to have 1 over, and then my sine value was root 3 over 2. If I do some keep, change, flip here, I'm going to have 1 divided by root 3 over 2. Keep the first 1, change division to multiplication, flip my second fraction, 2 over root 3. So that when I do that, I'm just going to end up with 2 over root 3. From here, I cannot have a square root in my denominator, so to get rid of it, I'm going to just multiply by a square root of 3 over a square root of 3. When I do that, these two numbers, 2 and root 3, cannot combine. I'm left with a 2 root 3 over root 3 times root 3 will give me the square root of 9, which will simplify down to 2 root 3 over 3. And that's what cosecant of 60 degrees is equivalent to. Let's try another one. If I have secant of 2 pi over 3. What would that be equivalent to? Take a moment and just set up your equivalent statement in terms of sine, cosine, or tangent. Great, so you should have 1 over cosine of 2 pi over 3. So from there, now I'm looking at my unit circle. I want to find cosine of 2 pi over 3. So I'm going to look to 2 pi over 3. My cosine value is this negative 1/2. So I'm going to replace cosine of 2 pi over 3 with a negative 1/2. So 1 over negative 1 over 2. If I do my keep changing flipping, 1 divided by negative 1 over 2. Well, that's the same thing as 1 times negative 2 over 1. So I'm going to end up with just a negative 2 in the end. You'll notice that when I have 1 divided by something, that something just ends up flipping, right? I get 1/2, negative 1/2 became a negative 2 over 1, but that actual value didn't change since I'm just multiplying it with 1. That's going to be true always. And before we move on to just one more practice with cotangent, I want to talk about that a little bit and how that applies to our tangent function. So when I think about equivalencies, I know that tangent is equivalent to sine of x, or sine of theta, sorry, I've been using theta, sine of theta over cosine of theta. So if cotangent is 1 over tangent, so I'm going to just work off to the side here, that's the same thing as 1 over, well, I know that tangent is sine of theta over cosine of theta. So it's the same thing as 1 over sine of theta over cosine of theta. If I do my keep changing and flipping here, I'm going to have 1, change division to multiplication, flip that bottom fraction. Cosine of theta over sine of theta. Oh, cotangent is the exact same thing as when you take cosine over sine. So when you take your x value and divide it by your y value. Now you can always get here by remembering that tangent is sine over cosine, and for cotangent you're taking 1 over tangent. Or if you know that you're pretty good at remembering these kind of things, like you're going to remember that cotangent is cosine over sine. If you know that you can remember that, go ahead and shoot for memorizing it. That's great. Let's do one more practice problem with cotangent, and then you'll get to practice a little bit on your own. So if I asked you for, let's go with cotangent of 11 pi over 6. Cotangent of 11 pi over 6. So for cotangent, I'm taking 1 over tangent, or 1 over sine over cosine, or I'm taking my cosine value, dividing it by sine. So that's the same thing as cosine of 11 pi over 6, divided by sine of 11 pi over 6. Okay, so from there I'm going to look at my unit circle. If I go to 11 pi over 6 down here, my cosine value is this root 3 over 2. Sine is a negative 1/2. So I'm going to replace those two values. Cosine is root 3 over 2. Sine is a negative 1/2. I'm going to write that out horizontally, so I've got root 3 over 2 divided by negative 1/2. If I now do my keep, change, flip, so I'm going to keep root 3 over 2, change division to multiplication, and split my second fraction, so I've got a negative 2 over 1. When I multiply straight across, I'll get a negative 2 root 3 over 2. The 2's cancel out, so that I get cotangent of 11 pi over 6 is a negative root 3. Just like finding tangent was a little bit more, or a little bit trickier than finding sine and cosine, finding cotangent has a little bit, or is a little bit trickier than finding secant and cosecant. So it's a little bit trickier, a little bit more time consuming, but you can do it. We're going to be, or you're going to be practicing on Delta Math for just a little bit. Maybe set a timer for about 10 minutes, and use those 10 minutes to practice the first 2 parts of the assignment up on Delta Math. Go ahead and pause. At this point, you should have practiced on Delta Math for a pretty long amount of time. If you had any questions, that was your chance to kind of work it out with me. If you didn't work out any of those questions, go ahead and just pause, and I can come and stop by and answer any of those questions that you still have. For those of you who did practice, we're going to move on to trig proofs. So this is kind of the second half of this video. Oop, my hand got stuck. There we go. We're going to be solving trig proofs. This is the last major topic of the year. After this, we will be completely done, which is something to celebrate about. So with that said, there are a couple things that I want you to set up just now on your page. So on one side, I want you to just set aside a box, and we're going to put all the stuff that we've learned today, all the stuff that we've learned about trig functions kind of in this box for right now. So what we've learned today, we've learned our reciprocal function, so I know that cosecant of something is 1 over sine of that same something. I know that secant of something is the same thing as 1 over cosine of that something. I know that cotangent of something is the same thing as 1 over tangent of that same something. I also know that it's equivalent to cosine of something over sine of something. The last one that we're going to add in is just tangent. We're going to be using this one. I know that tangent, it's equivalent to sine over cosine. And we're going to be using all 4 of these throughout some proofs today. Before we get started with proofs and we talk about what they look like, what they are, there are 3 rules that I want you to keep in mind as we're going through. Rule number 1, only change one side. Ever, so you're going to pick one side and stick with it. So there will almost always be 2 sides to your proof. You can only change one side. rule number 2 is that you can only substitute in what you know is equal. So big concept number 2, only substitute in what you know is equal. And number 3 is that you can only change one thing each step. So with proofs, I want to see your thought process all the way through, which means that if you think about changing a bunch of things at once, you actually have to do them one by one to get full credit for your proof. So you want to only change one thing for each step along your way. And so with that, let's take a look at a proof. We're going to be proving that tangent of x times cosine of x is equal to sine of x. So I'm going to stick with my 3 rules. I'm also going to use pieces of information from this box up here to answer and to evaluate that proof. So I'm only changing one side at a time. To help me do that, I think it's helpful to kind of draw a wall, kind of like what you did in Algebra 1 as a freshman when you were solving equations. But that being said, know that you're not going to be like multiplying by 3 on both sides or doing anything on both sides. You're only going to be changing one side of your trig proof the whole time. So the first challenge is kind of just figuring out which side to change. Almost always it's going to be the left-hand side that you're going to change, but really you're looking for which side has more going on. Like which side has more functions, which side has more multiplication, more division, that sort of thing. And in this proof, you'll notice that the left side has more going on, the right side only has sine. Okay, so step 2, or rule number 2, is only substitute in what you know is equal. So I'm going to look at what I know, or what I have. So I've got tangent of x times cosine of x over here on the left. Do I have something equivalent up here that I could substitute in for one of these 2 equations? Yeah. For tangent of x, I know that tangent is equal to sine over cosine. So I'm only going to change that one thing. I'm going to replace tangent of x with sine of x over cosine of x. But I'm going to keep the rest exactly the same. So cosine of x stays there, sine of x stays here. So this side is always going to stay sine of x. From here, so I could put this kind of over 1. If I were to multiply straight across, I would see that I've got sine of x times cosine of x divided by a cosine of x. And that's equal to sine of x. Okay, last step. If I look at what would cancel, oh, my cosine of x's end up canceling out. I'm just left with sine of x is equal to sine of x. Once you get 2 pieces that are equivalent to one another, you know that you're done. That's going to be your final answer to your proof. Let's try another. If I have, let's go with cosine of x times secant of x is equal to 1. Looking at this proof, which side do you think you're going to change? Great, we're going to be changing the left-hand side of our proof, which means that the right side is always going to say 1, no matter what we substitute in. So looking at that, and looking at kind of our box of stuff that we have up here, what's one thing that I could substitute in either for cosine or for secant that could help me out? So for secant, I know that secant is equivalent to 1 over cosine. So cosine is going to stay the same. Secant, I'm going to replace with 1 over cosine of x, and my right side is just staying the same as 1. If I were to multiply, so similar to the last one, if I were to multiply across in my fractions, 1 times cosine gives me cosine. 1 times cosine gives me cosine. Cosine over cosine, Well, I know that that is equivalent to 1. So I've got 1 equals 1. That's my sign that I'm done. The proofs will kind of look similar to that. But for practicing, you're gonna practice just with this concept of substituting in, simplifying. You're gonna be practicing that on Delta Math. And so we're going to be working through this problem, simplify 1 to 1 trig function or number. Before we do that, though, I do just want to, kind of another box off to the side, talk really briefly about exponents and your trig functions. So notation-wise, if I have something like sine of x, and that whole sine of x is being squared, because mathematically we're kind of worried about like, well, this exponent is really close to this x. A lot of people might be tempted to put the exponent with the x, but that would actually give us something different from just squaring sine of x. So notation-wise, we write the exponent as sine, and then your exponent to x, sine squared x. This, however, means the exact same thing. So both of these statements mean that you've got just 2 sine of x's, and they're being multiplied together. So sine of x times sine of x. So let's just take a moment and think. If you had 1 over a sine squared x, 1 over sine squared x, what do you think that that would be equivalent to? Okay, so maybe you said something like, well, I know that 1 over sine of x is cosecant of x. Maybe you said something like, I think it is a cosine squared x. Maybe you said you think it is something like sine of x. Who knows? One thing that I do notice is that there are 2 of these sine of x's. So I could expand this out to be 1 over sine of x times sine of x. And when I have a fraction like this, when everything is being multiplied in my denominator, I can actually split that fraction up into 2 pieces. I could have a 1 over sine of x times a 1 over sine of x. So if you think about that, I know that 1 over sine of x can be replaced with a cosecant of x. So I'm going to replace both of these with cosecant. Cosecant of x times cosecant of x. So that in the end, I've got 2 of these. It's going to end up equaling, so this will end up equaling in the end, cosecant squared x. So one thing to just note about exponents is that they don't actually affect your equivalencies at all, really. The only thing that changes is that if you have a function that has an exponent, your equivalent function has to have that same exponent. So if this were sine cubed, this would be cosecant cubed. But otherwise, not that much is going to change. So let's think about this function, or this question up here. I'm asking you to simplify to 1 trig function or to some number. So this time we actually don't have that 2 sides thing to stick with, but the other 2 rules still apply. You want to substitute in what you know is equal, and you're only going to change 1 thing each step. So looking at this expression, what could I substitute in for either sine squared or for cosecant squared? Okay, so I know that cosecant squared is 1 over, or cosecant is 1 over sine. So cosecant squared could be replaced with 1 over sine squared. And I'm going to leave my sine squared x exactly as it is. If I were to multiply across, so put that over 1, I'll get a sine squared x over a sine squared x, which is just going to equal 1 in the end. Some of these will be a little bit trickier than others. This was kind of a more simple one, but you're going to take kind of the rest of class just to practice with this on Delta Math. It's the last part of the Delta Math assignment. And then next week we'll come back together. We'll come all together and just really talk about trig proofs, how to solve them, what strategies you can use. So nice job with this.